Hey guys, good morning.
Good morning, ma'am.
Morning.
Good morning, ma'am.
Good morning, ma'am.
Good morning. Good morning. Where were we? So did you solve this? Did you solve this particular relationship? Did you solve?
Yes, ma'am.
What are you getting? Solve करने के बाद मैंने कहाँ छोड़ा था? ओके log x 1 plus x की वैल्यू डाल दी थी, log 1 minus x की वैल्यू भी डाल दी थी. Then okay. So basically, are you getting this particular equation?
Yes, ma'am.
थोड़ा सा इसको मैं बड़ा करती हूँ, बहुत छोटा दिख रहा है लाइट. Okay. So if I further solve this equation, I was basically trying to solve the relationship for something called as deviation from state of maximum probability, and then I defined, basically I started क्योंकि काफी दिन हो गए हैं, so let me just recapitulate. I started from a point where I was calculating when there are n particles to be distributed in two compartments. Okay, then the number of compartments were basically calculated as number of macrostates were calculated equal to n plus 1, and then I said that the state, any state which is having the maximum probability, is being written by the value r is equal to n by 2, that is when the number of particles are exactly half. Okay, so the macro state with maximum probability is nothing, the macro state is being defined as n by 2 comma n by 2. Okay, any macro state that is being defined for the maximum probability is n by 2 comma n by 2. Okay, so then we said that let us have an deviation, very small deviation from the minimum probability. Okay, from the state of minimum probability, and that deviation is very small as compared to the total number of particles. And I said that that deviation, how the deviation is going to change in the final expression, that we were basically calculating. Okay, so with this expression I shall write again a log of 1 plus x and n plus x, and this I was solving n minus x and log of 2. So if I solve it further, what do I get if I just open this relationship? So I am just writing log of m plus n natural log n by 2. Natural log को मैं log ही बोलूंगी, natural word I am not going to use, minus, further solving it, n by 2 plus x into log n by 2. Can I apply Taylor theorem here? So if I will apply Taylor here, what I will get? 2x plus n में what I'm going to get?
2x plus 2x upon n.
This is the Taylor x upon n plus minus 2x square upon n square, and so on. I'm going to neglect the higher values. Okay, then minus, what do I get? Minus n by 2 minus x. Yes,
Ma'am, your voice is not clear.
my voice is cracking or what?
Not clear. It's lagging.
Just a second. I'll just reload. Give me 1 second. Okay, now I am audible. My connection seems to be good. Okay. Yes, आगे. Yes.
मैम
Harshal?
पिछले वाले स्टेप में n बाय
Okay.
2 प्लस x के बाद log ऑफ n बाय 2 मिस कर दिया.
कहाँ पे बेटा? इस इक्वेशन में?
नो मैम, इसके नीचे आपने जो अभी सॉल्व किया टेलर
ये?
थ्योरम लगाई.
एक मिनट. मैं रब करती हूँ. यहाँ से आप कह रहे हो?
यस मैम.
ओके. क्या आना था? बोलो.
log ऑफ n बाय 2
लॉग ऑफ. यार अब विजिबल तो है ना, क्योंकि मुझे काफी छोटा और पतला दिखाई दे रहा है. इट्स विजिबल नो? ओके. लॉग
विजिबल
ऑफ
है.
n बाय 2. ओके.
अब लगाएंगे ना टेलर थ्योरम.
ओके.
प्लस 2x अपॉन n
2x अपॉन n
माइनस
माइनस
2x स्क्वायर अपॉन n स्क्वायर.
n स्क्वायर. यस.
नेक्स्ट भी करना है मैम.
हाँ.
प्लस
नहीं, नेक्स्ट इज गोइंग टू बी द हायर.
ओके.
फिर आएगा ये वाला टर्म माइनस n बाय 2 माइनस x
x and then log of
का
n by 2
log of n बाय 2
plus minus
माइनस 2x
2x
बाय
upon n
n माइनस
minus
2x
2x
अपॉन n
square.
का होल स्क्वायर इंटू 1/2. यही आ रहा है.
Yes ma'am.
सिंपल. दिस इज व्हाट इज कमिंग. ओ राइट. सो बेसिकली थोड़ा छोटा लिखने की ट्राई करती हूँ यार मैं, तो उस पर लिखा नहीं जाता. ओके. सो व्हाट आई एम गेटिंग इज log of pm plus n log as it is n log n by 2 minus n by 2 plus x into log of, मैं दोबारा लिख रही हूँ इसको, log of n by 2 plus 2x upon n minus 2x square upon n square minus n by 2 minus x log of n by 2 minus 2x upon n minus 2x square by n square. Right? Then I'm getting log of pm. मैं x की टर्म्स को अंदर मल्टीप्लाई करना शुरू करूंगी. प्लस n log n by 2 माइनस n by 2 इंटू log, मैं तुम्हारे लिए ब्रॉड कर रही हूँ, ठीक है. n by 2 आप इसको डायरेक्ट भी कर सकते हो. 2x अपॉन n माइनस 2x स्क्वायर अपॉन n स्क्वायर माइनस पहले ये वाली टर्म देन ये वाली टर्म. यू कैन डायरेक्टली मल्टीप्लाई इट, बट फॉर एवरीवन्स क्लैरिटी आई एम डूइंग दिस, राइट, ताकि ये सबको क्लियर रहे.
Yes.
Firstly, I'm just multiplying n by 2, then this x with the whole this term, then plus x like minus आएगा ना, minus x because it is minus outside. So I'm getting log n by 2 plus 2x upon n minus 2x square upon n, sorry, n square. Okay, then this particular term, and I'm getting n by 2 minus n by 2 log of n by 2 minus 2x upon n minus 2x square upon n square plus x. This is becoming plus x into log of Mansha x n by 2 minus 2x upon n minus 2x square upon n square. So multiplying all the terms, I am getting the term log Pm plus n log n by 2 minus n by 2. अब मैंने क्या किया है? Just taken the n by 2 term log n by 2 plus 2x upon n minus 2x square upon n square minus log n by 2 मैंने अब क्या किया है? इन वाले टर्म्स को इकट्ठा किया है, दिस टर्म एंड दिस टर्म, क्योंकि दोनों में n by 2 है. So I have just taken n by 2 common. Okay, I have just taken this n by 2 common. Screen ही हिल जाती है. Okay, n by 2 common. I'm getting 2x square and then this. हाँ जी.
Light.
क्या हुआ?
We are not able to visible. Its screen is not visible clearly.
Now.
Pen is very light.
Now.
Yeah, it's clear now.
फिर मैं इसको क्या करूँ ना, नीचे लिखूंगी. हाँ विकास 2 मिनट. फिर मैं इसको ना नीचे नीचे लिखते जाऊंगी, ठीक है? Rather I will not expand the screen, but the whole screen is the whole writing is going to continue up till below. Okay, so I am getting what is log n 2x by n, getting this particular term 2x plus log n by 2 minus 2x square upon n square, then minus x log n by 2 plus 2x by n minus 2x square by n square minus log of
on n आएगा.
एक मिनट, कहाँ पे?
मिस के ऊपर वाली जो लिखी आपने इक्वेशन.
हाँ जी.
2x minus 2x upon n आएगा.
ओके 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 ओके. n plus 2x square upon n square. अब सॉल्व करो और मुझे जल्दी से बताओ क्या आ रहा है. हरी अप. The final expression, what you are getting. Hurry up, hurry up, hurry up. What are you getting for log of px is equal to log of pm. सॉल्व करो, ये कुछ कुछ आपस में कैंसिल हो जाएंगे. जैसे मैं तुमको बताती हूँ, this is going to cancel with this and then 2x square is going to cancel with this. There are many terms which will be cancelled. Hurry up. Please tell me what I'm left with, because I need to write the final expression. Hurry up. Mansha, yes Mansha, where are you? कोई रिस्पॉन्स नहीं आ रहा आपकी तरफ से. रक्षा, तोशिता, पता नहीं कहाँ हैं ये लोग. अच्छा ओके. Toshita, hurry up, tell me what are you getting as an expression after solving this. You should ideally get, I will write it. मैं अब इसको बड़ा कर रही हूँ स्क्रीन को. I don't think मुझे ऊपर वाले एक्सप्रेशन की जरूरत है. So मैं अब शीट ही बदल रही हूँ. Just 1 second. So what you are getting? I am getting this log of. Log of. यार ये इतना छोटा क्यों आ रहा है? So I am getting log of px is equal to log of pm plus 2x square upon n minus 4x square upon n. So which will be log of pm minus, rather मैं एक जो उसमें लिखती हूँ, I will not write. Please take time to solve this. ऐसे ऐसे गड़बड़ी मत कर देना. Take time. Hurry up. Hurry up. ढंग से सॉल्व करो. माइनस माइनस की मिस्टेक मत कर देना.
मैम रिजल्ट तो यही आ रहा है बट एक चीज मिस हो रही है यहाँ पे, n log n/2.
n log n/2 मैं बताती हूँ तुम्हें. n log n/2 कहीं n/2 दो बार आया है. याद है तुम्हें? एक माइनस n/2 दो बार आया तुम्हारे पास. माइनस n/2 log n/2 माइनस n/2 log n/2. तो जो पीछे वाला आपके पास n log n/2 है उससे कैंसिल हो जाएगा.
ओके.
ध्यान से देखो, ध्यान से. यस यस यस. डू इट. टेक टाइम. ये इतना इजी नहीं है. ये कुछ डेरिवेशन थोड़ी सी लंबी है तो प्लस माइनस की गलती हो जाती है. इट्स ओके. Getting it? 26 people with no responses. That means you are not doing it. लास्ट ही तो टॉपिक है ये. लास्ट है, सेकंड लास्ट टॉपिक. उसके बाद तो कुछ बचा ही नहीं है चैप्टर 1 में. हरी अप. आर यू गेटिंग इट? 22 people not responding. मैम वो n/2 का नहीं हो रहा है. क्या नहीं हो रहा है n/2 का?
मैम बिकॉज वो तो टेलर एक्सपेंशन से बाहर था ना, n log n/2, तो वो तो वैसे ही रहेगा.
नहीं बेटा.
मैं बाकी कट होके आ गया रिजल्ट -2x square upon n.
नहीं नहीं नहीं. Somewhere here you are getting this. This is n/2, no? n/2 log n/2. ये आ रहा है log n/2. यहाँ पे आ रहा है this is log n/2. Here यहाँ पे ये कैसे कट जाएगा तुम्हारा? मुझे समझ में नहीं आया. ये आपस में कट गया. This is 2 log n/2. This is this term and this term. They are going to become 2 log n/2. And then if you multiply this, it is going to become n log n/2. हर कोमल
यस मैम.
आ रहा है? This is here, no? n/2, no? This particular term.
Yes,
Then if you
ma'am.
multiply n by 2 with this particular term, आपके पास n log n by 2 बचेगा minus n log n by 2.
Okay.
आ रहा है?
Yes, ma'am.
Clear? So what you are left with is px is log of px. कितना आ रहा है? px is equal to log of pm minus
Minus
2x
2x
square upon
n.
n. Take log to the left hand side. Taking logs to left hand side, what I am getting? Log of px minus log of pm is equal to minus 2x square. Are you getting it? Minus 2x square divided by n. Minus 2x square divided by n. Are you getting it?
Yes, ma'am.
All right. Now take the logs together. Take the logs together. क्या आएगा? Log of px by pm is equal to minus 2x square by n. आ रहा है? So अब अगर मुझे log हटाना है तो मैं क्या करूंगी? What am I going to do now? Taking the exponentials. So if I take
पार हो जाएगा.
exponential, I will just get e raised to the power minus 2x square upon n. Clear? Clear?
Yes, ma'am.
Okay, so if I just split this minus 2x square, so what I will get is e minus n by 2, कुछ नहीं कर रही हूँ, minus n by 2, 2x upon n का square. Clear? n से ऊपर नीचे मल्टीप्लाई किया n by 2 से n by 2 से. Clear?
Yes, ma'am.
Raise your hands up if this is clear to you. Raise your hands if this is clear to you. Done. So let us suppose this 2x upon x upon n is equal to any function f which is called as fractional deviation which is called as fractional deviation from most probable state. From most probable state. Okay, so I can write this term as px upon pm is equal to e raised to the power nf square upon 2. This is the final term. This is the final deviation. And just to analyze what is the meaning, I will rather say we are going to analyze this what is px and pm, right? So अगर आपको किसी भी मोस्ट प्रोबेबल डेविएशन की एक मिनिमम डेविएशन निकालनी है, it is going to be minus nf square upon 2. So just to discuss what is the physical meaning, I will take an example. Let me just keep your calculators with you. Let us analyze let us analyze one case where number of particles are n, okay, and the minimum deviation is f is equal to 0.1%. Yeah, 0.1%, right? Suppose it is 0.1%, that means f is equal to 0.001, that is equal to 10 raised to the power minus 3. Okay, so what is the value of px by pm? What's the value of px by pm? It comes out to be e minus n by 2 into 10 raised to the power minus 3 ka square, and it comes out to be minus n upon 2 into 10 raised to the power minus 6. Okay, and just 1 second. Just 1 second. And px by pm is written as 1 upon e n by 2 10 raised to the power minus 6. Okay, so this ratio is basically different for all the values. If suppose the number of particles, okay, this is अगर आपके पास एक small percentage है fractional deviation की 0.1%, if suppose, अरे ये क्या हो रहा है, if suppose the number of particles are 10 raised to the power 3, number case 1, if your n की value, if your number of particles are 10 raised to the power 3, then what is the value of px by pm? What is the value of px by pm? Please give me. Just आपको इस equation में put करनी है, nothing else. Here you have to substitute 10 raised to the power 3, and please calculate it. Hurry up. You will get, what are you getting? What are you getting?
1 by e raised to power 10 raised to power minus 3 by 2.
If the number of particles are 10 raised to the power 3, okay, 1000 particles hai, so I am getting e 1 upon 0.0005. Okay, now if number 2, if the number of particles are 10 raised to the power 6, then what are you getting? If then what are you getting? Hurry up. Oh, 1 नहीं है यार, ये नहीं है, 0.005. If it is 10 raised to power 6, then what are you getting? 1 upon e. कितना आ रहा है? Hurry up. What are you getting? Yes. अरे n by 2 में डालो, कितना आ रहा है? Are you getting?
मैम e raised to power 0 हो जाएगा ना?
कैसे होएगा? 0 तो किसी भी हालत में नहीं हो सकता. For 10 raised to the power 9 कैलकुलेट करो, कितना आ रहा है? 10 raised to the power 12, it is going to come e raised to the power 1. And if you see a trend, as the number of particles are increasing, what is happening to px by pm? What is happening to px by pm? This value is decreasing. Can you see this particular? Because the denominator is getting very, very small. So as the number of n particles are increasing, the probability for 0.1% deviation, that the probability that the system is going to deviate from 0.1 fractional deviation is going to decrease. is going to decrease. Okay, and right, if I just plot a graph between two, if I am just plotting a graph between two, I get a graph like this. If this is the point, I will get a graph like this. Where I am plotting this fractional deviation with px by pm. px by pm. This is 0 and अगर मैं fractional deviation 0.1 or minus 0.1 की बात कर रही हूँ, right? So basically the graph is called as the probability distribution curve. Probability distribution curve, and as the number of particles are increasing, the graph is getting narrower. Narrower in the term कि जैसे ही आपके this is for 0.3, 0.1, 0.2, this is for 0.2, 0.3. As the n is increasing, the graph, this graph is for n1, this is for n2, and this is for n3, usually saying that n1 is greater than n2 is greater than n3. So as the number of particles are increasing, the graph is getting narrower, indicating that probability of distribution, probability of deviation is decreasing as the number of particles are increasing. So the more number of particles you have, the lesser probability of the deviation becomes. Okay, the lesser particles you have, the more will be the probability that the result is going to deviate from the most probable state. Whereas if you go on increasing number of particles, the distribution is going to have less deviation. That means if we are taking into account large number of particles, the result will be pretty cool rather than the less number of particles. And hence we say that statistics, the more number of particles, the more number of results for the most probable macro state we get in calculations. Okay? Okay?
Yes, ma'am.
Clear? क्या रह गया तुम्हारे सिलेबस में? Just 1 second. अच्छा, तब तक एक न्यूमेरिकल कर लो तब तक. What is calculate the percentage error? Calculate the percentage error. नहीं, अच्छा छोड़ो इसको. ये तो तुम्हारे उसमें है ही नहीं, मैंने कराया नहीं है ज़्यादा. Just a second, I'll just switch to what is the syllabus that we've been studying. Course overview. Chrome tab, content. Okay, so in the course overview, information, syllabus topics, I am done till here. अब हमारे पास बचा है इक्विलिब्रियम स्टेट ऑफ डायनामिक सिस्टम. कल हम करेंगे व्हाट इज स्टैटिक एंड डायनामिक सिस्टम, और एक आर्टिकल रह गया डिस्ट्रीब्यूशन ऑफ indistinguishable particle in k compartments of unequal size. Equal size so we've done. Okay, and I will just tell you what is this. Okay, revise this particular डेरिवेशन एक दो बार करना, एंड आपके फाइनल एग्जाम तो सब्जेक्टिव ही होने वाले हैं, राइट? द डेरिवेशंस आर गोइंग टू कम. ओके, अभी तक आपके एमसीक्यूज हो रहे थे, लेकिन फाइनल एग्जाम तो डेफिनेटली इट इज गोइंग टू बी सब्जेक्टिव. सो द डेरिवेशन आर ऑफ रियल इंपॉर्टेंस. लेट मी जस्ट स्लाइड अप टिल so what is a static and a dynamic system. Let us study. A static system. What do you understand by static and dynamic system? Any system which whose constituent particles are going to be at rest, right? They are called the static systems. And if the constituent particles do not remain at rest, they are called as dynamic system. And in the static system, the particles, the number of particles, they cannot change their position by their own selves. Some kind of external force is required to change their positions. But in case of a dynamic system, the constituent particles keep changing their positions. That means now the positions are being said as in the terms of what? As in the terms of microstate. So if a constituent particle of any system, any given system can move, so that a system is going from one microstate to another microstate, it is said as a dynamic system. And the dynamic system, definitely the internal forces can make the particle sweep from one state to the other state. For example, most of the first example of a static system, can you give any example of a static system? Any example of static system जिसमें अपने आप से change नहीं होंगे? Any example of static system? Anyone? Just an initial guess. For example, a system of coins, or maybe a system of dice. It is a perfect example of the static systems. When the coins are tossed, they fall in a manner that you are getting either head or either tail, but they cannot sweep by themselves. अब अगर एक कोई head आया था, it cannot just become tail by itself. It is a static system. But what is a dynamic system? For example, gas sample is an example. Any gas which is kept in a container, and the molecules of a gas, they are always in motion. They are, colliding with each other, and they are the particles, the n particles of that particular gas, which are just randomly moving. They are changing their states time and again. If you talk about their state of position, energy, and momentum, they are changing their states. Okay, then such systems are basically said to be called as dynamic systems. And these systems, they are disturbed by, if in case they are disturbed by some external causes, and then we let those systems to just evolve and थोड़ी देर उनको वैसे रहने दे, then the system, okay, they tend to stay near a macro state with the maximum thermodynamical probability, जिसको usually हम equilibrium भी बोलते हैं ना, कि थोड़ी देर में equilibrium पे आएगा. But अभी I'm not going to talk about equilibrium. But if we keep those particular gas or making or the working substance to itself, okay, they are going to stay in a macro state, which is going to have the maximum thermodynamical probability. That means they basically stays in a state called as most probable macro state. Okay, they are staying in a state which is called as most probable macro state. So the next article, I think we shall be doing it tomorrow. There's no point doing this today. And with the next article, I shall be completing the whole division of phase space. Yes. Then I shall be going to max MB statistics. बस एक दिन का रह गया मेरा ये topic, and we'll be done. How many of you got the notes? I have sent some PDF. I had sent some PDF on the group. How many of you have checked that PDF? Yes. How many of you have checked that PDF? Yes, काम की है. Is it worth? Is the PDF worth?
Yes, ma'am.
Okay. Now you need to see all those notes, as well as at least for MSTs तुमको सारा देखना पड़ेगा. And apart from notes, what has been taught to you? Again, आपसे जो भी मैंने कराया मैक्सिमम उसी बुक से कराया है. So please have a look on that. Start studying for your MSTs. Very less time has been done. Chapter 1 is almost over. Only one article is left, and tomorrow I shall be completing your chapter 1. Okay. ओके एंड तुम्हारा ना रिस्पॉन्स थोड़ा कम आ रहा है, थोड़ा सा तैयार भी रहना. एनी गिवन डे और सरप्राइज टेस्ट कैन हैपन. तुम्हारे क्विज़ हो सकते हैं, सो बी प्रिपेयर्ड. असाइनमेंट इज गोइंग टू बी ओपन आफ्टर द एमएसटी. मैं आपको एमएसटी के पहले दे दूंगी एंड इट इज टू बी डन आफ्टर द एमएसटी, या शायद मैं एमएसटी के पहले ही ओपन कर दूं, ये भी इंपॉर्टेंट नहीं है. So by the time start studying, guys. Okay, now you can leave. I'm done with today.